I get so jealous of the people who claim to have photographic memories. Most of us don't. Now, students participating in a psychology experiment attended several lectures on the subject, and they were given an exam, and they scored very well. Every month for a year after the exam, the students were retested to see how much of the material they had remembered. The average scores for the group are the human memory model. So this model, including the natural log, is a good model to use that shows how people retain information. Now, let's consider the natural log function. Here it is. Here's your generic natural log function. Look what's happening to it. Of course, we're moving it one spot to the left, and our new asymptote will be here at -1. This 6 is a vertical stretch, so it's stretching it this way, but the shape integrity will remain the same. The negative on the outside affects the y, so a positive y becomes negative and a negative y becomes positive. So let's look at what's happening with this graph here. Instead of going like this, if we reflect it, it's going to be like this. So here is our graph, and then outside affects the y. We're going to move it up. So finally, our graph will look something like this. Now, of course, we have this asymptote at x equals -1, but time is always going to be positive. So we're going to start at t0 and move to the right. So that will be the shape of our graph. For reasons we just talked about, our graph is going to have the general shape like this, which is expected. We don't remember as time goes on. This is our time axis here. As time increases from 0 up to, say, 12, the memory, the amount of material we remember is going to be less and less and less. Unfortunately, unless you're lucky and you have a photographic memory. So the first question is part A. What is the average score on the exam at t equals 0? Well, f of 0 will be -6 natural log of 0 plus 1 plus 75. Well, we know that that simplifies to -6 natural log of 1 plus 75. Now, we can do this. Natural log of 1, or log base e of 1. E to what power gives us 1 is 0. So this is going to be -6 times 0 plus 75. Why is that again? I'm looking at this part here. Natural log 1 is the same as log base e of 1. And we're saying always e to what power? The answer to a log problem is the exponent. E to what power gives us 1? Of course that's 0. So we get a 75 here. Here's our point, 0.75. So that's the initial information retained. At 2 months, how much material has been remembered? Well, that would be t equals 2 because t is in months. I did not say that. So the function value at 2 will be -6 natural log of 2 plus 1 plus 75. Now, I don't happen to know what this would simplify to natural log 3 plus 75. Note, this part here means log base e of 3. And so we're asking e to what power gives us 3? I don't know that answer. So in this case, I'd have to rely on my calculator. And when I put these numbers in, and you can check me at home, I get 78.41, which is here. Here at 2 months, I'm going to get 68, not 78, 68.41. Good thing it's 68, because if it was 78, that would mean my retention is going up higher than it was initially after the lecture. So I'm expecting a number less than 75 based on my graph. And I got it, so I'm happy. And here is a very sad story. How about 6 months later? How much of the material had the students retained? Well, we're going to find f of 6, which would be -6 natural log of 6 plus 1 plus 75, which of course simplifies to natural log of 7 plus 75. And this part here is log base e of 7. And we're asking E, 2.71828, to what power gives us 7? I don't know that offhand, so I'll have to resort to my calculator. I am expecting that the students will retain less than 68% of the material because my model shows that it's going down, down, down. And when I crunch the numbers, I get 63.32. So you can see we get what we expected. Now, many of you will be saying, that's a very sad story, Mr. Karn. How do you retain your mastery of a lecture? Well, one of the things they have found is if you sit shortly after the class, it has to be the same day, and you read your notes and you fill in anything from the lecture that you didn't get a chance to write down, and you go over your notes in that manner, then you will actually increase retention. So even those of us without a photographic memory can retain more if we're taking notes and then going over those notes must be the same day as the lecture.